Okay, so this is going to be part 2 of trig. This is going to be finding angles using trigonometry, the stuff you started with yesterday. You're still going to be using your sine, cosine, and tangent, but now you're going to be using that -1 button for each one of those. So let's go ahead and get into this. So starting off with, we're going to review the concept of those ratios. Every single one of these can be done as a fraction and a decimal. And this is from your notes from yesterday. This is kind of reviewing the concept of those ratios. So starting off with angle P for the first ones, right here. If you're on angle P, this piece right here would be the adjacent side because it touches it. The piece directly opposite it would be the opposite side. And then the hypotenuse is always the hypotenuse. That never changes. So because of that, we can go set up our little ratios. Remember, we're using SO, CA, TOA when we do this. And for SOHCAHTOA, for sine is going to be doing opposite over hypotenuse. So for opposite, that'd be 8 over the hypotenuse, which would be 17. That doesn't reduce at all, so we just turn it into a decimal with that second and then the arrow, which would put it at 47.47. For the next one, cosine of P is going to be adjacent over hypotenuse. So adjacent is going to be 15, hypotenuse is going to be 17. So 15 over 17 reduces down as a decimal to 0.88. For the next one, tangent of P would be doing opposite over adjacent. So opposite would be 8 over the adjacent, which would be 15. And 8 over 15 again does not reduce, but it does turn into a decimal at 0.53. Now, from there, we're going to change things up and we're going to look at the other angle. The other angle is going to be angle R. Remember, no sine, cosine, or tangent of the right angle, so nothing of Q. But for R, sine, cosine, and tangent, again, we're going to be dealing with opposite now as this side, the 15, because it's now opposite our angle R. The 8 is adjacent to it because it touches that angle R. And the hypotenuse, as I stated before, is always the hypotenuse. So from there, sine of R would be dealing with opposite over hypotenuse. So opposite would be 15, hypotenuse would be 17. 15 over 17 goes as a fraction, and then the decimal for that, since it can't reduce, would be 0.88. We already did that here, so I didn't have to figure that out. And then cosine of R. Cosine of R is going to be adjacent over hypotenuse, so it's going to be 8 over 17. 8 over 17 again doesn't reduce, but its decimal is going to be 0.47. Okay, last one is going to be right here, a tangent of R. Tangent of R right here is going to be, tangent is opposite over adjacent, so opposite over adjacent would be 15 over 8. You can have improper fractions, that's perfectly fine. And 15 over 8 as a decimal turns into 1.86. Okay. So now that we have reviewed the concepts of the trig ratios, now we need to teach you how to find angles. I've got, I think, 4 or 5 examples of this, so let's go through and show you what this means. Okay, so right here, we are trying to find the measure of angle A. In this picture, angle A is right here, so I'm going to put an X right here. Right here, angle A is right here, so I'm going to put an X right here. That helps me identify what I need to get. It also helps me set up my trig ratio. So I'm going to be dealing with the opposite side right here and the adjacent side. If I'm dealing with opposite and adjacent, that means I'm going to be dealing with, remember, SO, CA, TOA. Everything is based on that. So it's going to be dealing with opposite over adjacent. So that's going to be dealing with tangent of X is equal to the opposite side, 23, over the adjacent side, which is 11. Whenever you have an X that is on this side that's an angle, you're going to rewrite it as tan -1. And you're going to switch the X with a fraction over here. So it's going to be 23 over 11 equals X. So to type this on the calculator, you would type 23, fraction button 11, second tangent That gives us 64.4 equals x. We only need one number behind the decimal because we're rounding degree measures to the nearest degree, which means the nearest whole number. So that would round to 64 degrees. That would be your final answer. Again, to type that in, it's just 23, fraction button 11, second tangent. Whenever you see this little -1, you got to hit the second button. You use that anytime you're finding an angle. Okay guys, here we go on the next one. Since this is my unknown angle, I'm looking at opposite right here and hypotenuse. If I'm looking at opposite and hypotenuse, I'm going to be looking at sine of x is equal to 18 over 27. That's going to be sine -1. Remember, every time you have an x there, you switch them. You change it to -1. Make a sine -1 of 18 over 27 equals x. To type that again, I'll type it with you. It's going to be 18, fraction button 27, second tangent, second sine, I apologize. 18, fraction button 27, second sine equals. Alright, when we do that, it's going to be 41.8. And 41.8 would be 1 with an 8 behind it. That's going to round up to 42, which make our final answer right here, 42 degrees. Okay, let's get our next ones done. On our next one, we're finding the measure angle A again. So on both the A's, I'm going to go in and put an X. It makes it easier to follow this. Here and here. This is going to be the adjacent side. This is going to be the hypotenuse. I know it's the hypotenuse because it's across from my right angle. Adjacent and hypotenuse using SOHCAHTOA is going to be cosine of x is equal to the adjacent 3 over the hypotenuse 15. Yes, it'll reduce. It doesn't help you to reduce it. It'll do it for you when you do the math. Leave it alone. Anytime you have an x here, you're going to switch these two. You're going to make it cosine -1. That's what the switching does. And then it's going to be 3 over 15 equals x. So 3, fraction button 15, second cosine equals, that's going to give you 78, sorry, my computer cut out for a second, 78.4 equals x. An 8 with a 4 after it would stay the same, so it'd be 78 as our final answer. So this angle right here would be 78 degrees. Alright, for our last one right here, we're going to be dealing with opposite and adjacent, which means we're going to be dealing with tangent. So it's going to be tangent of x is equal to 6 square roots of 2 all over 20 square roots of 2. Now, I will say, if you have something like this, make your life easy. If you have a radical on top and a radical on bottom that will cancel out, yes, go ahead and do that. Cancel those out before you do any switching, so that when you type this in, it will be much easier to type. So this will be tan -1. We would switch these two. It'd be 6 over 20 is equal to x. So that'd be 6, fraction button 20, second tangent equals, that's going to be 16.6 equals x. A 16.6, a 6 with a 6 after it, would round up to 17. So I'm going to use that 17 here, and this angle would be 17 degrees. Good. Okay guys, we only have one last problem, but it's got a couple different parts to it, so let's go ahead and knock this one out. So, in order to solve a right triangle, that means to find all its missing pieces. That's what's meant by solve the right triangle. So, this means you have to find everything that's missing in here. So first thing I'm going to do is look at this triangle and see what I've got and see what I can find. So the first thing I notice automatically is that I can find this missing side right here, this x, because I know two sides of a right triangle. Anytime I know two sides of a right triangle, I can use Pythagorean theorem. 5 squared plus 9 squared equals x squared to find that missing piece. 5 squared is 25. 9 squared is 81, equal to x squared. 25 and 81 would give me 106 equals x squared. I'm going to take the square root of both sides, and I'm going to take that and I'm going to round that off. So when I take 106, hit the square root button, it's going to round, kind of strange, it's going to round to 10 point, it's a 29 with a 5 after it, so it rounds up to 30, which is the same thing as 10.3. You can write 10.3 or 10.30 equals x, and we're going to write that right here, 10.3. Now the other things that I'm missing are going to be this angle right here and this angle right here. I'm going to use the 5 and the 9 to find both those angles because those are not rounded answers, so I'll get an exact if I do that with the 5 and the 9. I'm also going to think about, well, I'll show you when I get there. Let's start with one of these angles. Let's start with y. So when I look at y, this is going to be adjacent, this is going to be opposite. So if I've got adjacent and opposite, I'm going to be dealing with tangent of y is equal to 9 over 5. Whenever you have a variable right here, you are going to switch them and you're going to change it to tangent of negative 1 equals 9 over 5. Excuse me. Tangent negative 1, 9 over 5 equals y. Say that correctly. So you would type 9 fraction point 5 second tangent equals, it's going to give you 60.9 equals y, which we've got to look at rounding. A 0 with a 9 after it would round up. So that would make that angle 61. Now guys, if I've got that angle, I don't need to do trig to do this other angle. I know that every triangle is going to add up to 180. So I'm going to add the 90 plus the 61 that I've already got. That's going to give me 151. And 180 minus that 151 would leave me 29 for my last angle. There we go. So my three things that I found were this side length using Pythagorean theorem, this angle using trig, and then this angle using the fact that every triangle adds up to 180. 3 different methods to find my answers. Okay guys, that's our notes for today. Go ahead and get started on your assignment.